Alright, let's take a moment to think about equivalent fractions. Now, you want to remember the word equivalent, okay, means like equal, okay? So we're talking about fractions which are going to be of an equal status. They're just cut up a little differently. So when I look at a fraction, let's say we're looking at fourths, okay, and I have 2/4. I can represent this same amount here in a different way. Now, looking at the diagram I just drew, hopefully you see that that is equivalent to half. Now, mathematically, there's always an explanation as to how we came up with these numbers. And I could take 2/4 and I can see that they're both divisible by a common factor, and that factor is 2. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So I know that 2/4 and 1/2 are equivalent. But I could also take that fraction, and if I have my 2/4, I could also make more cuts. And now I see that I have 1, 2, 3, 4, 5, 6, 7, 8 parts. And of those 8 parts, 4 of them are shaded in. So 4/8 is equivalent to 2/4, as well as 1/2. So when I go back to my original problem, which was 2/4, I know that 4/8 is equivalent because I can multiply the numerator and denominator by the same number, and I could get 4/8. So the idea of equivalency is that all of these fractions are equal amounts, even though they're maybe cut in different ways. So when I think about how can I make equivalent fractions, there's 2 ways you could do that. The easiest is to multiply both the numerator and the denominator by the same number. So again, 1/2. As long as I multiply that by the same number, let's say thirds, that would be 3/6. I can tell that 1/2 is going to be the same as 3/6. It's going to be the same amount. They're equivalent. The other way that I could come up with an equivalent fraction is to divide. That gets trickier because you would need to make sure that you had a common factor for both the numerator and denominator. So what I mean by that is, let's say that I had 6/8, okay? I would have to know that 6 and 8, they share 2 as a common factor. So I could divide both by 2, and I could see that 3/4 would be an equivalent fraction to 6/8. Alright, so while we're on the thought of equivalent fractions, why don't you give it a try? So, let's say I had 1/4. How could I make 1/4 equivalent to another amount? Could I multiply? Could I divide? Could I do both? Take a moment, pause this video, and try to make 1/4 an equivalent fraction. Okay, so hopefully you came back and you noticed that I would not be able to divide this down any smaller, so instead I would need to multiply. Now when I multiply, it would almost be an infinite possibility of what you may have chose to multiply by, so I'm going to keep it small. I'm going to multiply by 2. So when I multiply the numerator and denominator both by 2, I see that 2/8 is a possible equivalent for 1/4. And I could actually go ahead and keep multiplying my equivalent fractions by the same number, and I would keep getting different numbers that are equivalent to one another. So I could see that 8/32, 4/16, 2/8, and 1/4 are all equivalent fractions to one another. Alright, so let's think about a number like 5/10. Can you make that equivalent? How could I choose to do that? Pause it, try it, see what you come up with. Alright, so hopefully you thought about it and you saw 5/10. Well, I could multiply that as I did the first problem by 2 and keep going that way. But 5 and 10 do have a common factor. So perhaps you noticed I could actually choose to divide to make an equivalent fraction. So one of the common factors that they share is 5. So as long as I take the numerator and denominator and divide that by the same number, I can get an equivalent fraction, 1/2. So 5/10 and 1/2 are equivalent to one another. And as we know, 1/2 is equivalent to many different things, so I could create a whole list of equivalent fractions like 5/10.